Isotopes. Isotopes means same atomic number but different mass number. So time of Dalton, is it isotopes are there? Time of Dalton, nobody knows the isotopes. By the time not discovered, later only they discovered. That is why it is a drawback of Dalton. Understanding different mass number. So remember, atomic number is decided by number of protons. Number of protons we will study in this chapter only. Mass number is means number of protons plus number of neutrons. Is it okay, Mitakshri, Harini? So number of protons plus number of neutrons. Remember, number of protons in a given element cannot be changes, but number of neutrons can vary. So now if we take this chlorine, all of you remember, this chlorine, first one, 17 protons, 17 plus 17 neutrons plus protons, totally which is equals to 35. So if we take the second one, only 17 protons. Protons is remains constant, but here 17 protons plus 19 neutrons. That is why total is equals so much, guys. How much? 37. Understanding? 37 is the mass number. So that is why this atom and this atom not having the same mass. Even though they are the same element, the mass is not same. That is why it is a drawback of Dalton's theory. Understand, everybody? Yes, please. Yes or no?
Yes, sir.
Yes. Next, you might be remember that. All of you remember. All of you read again fifth point. Sorry, sixth point. Read, everybody. Sixth point. Sixth point. Everyone should read. What is the sixth point? Hare?
The atoms of different element, different mass, size, and chemical properties.
Very good. Now, if we take this is what it is, but this is also proved wrong later. So, some elements may be having different, some atoms of different elements having the same mass. Let us see how it is. So, remember all of you, John Dalton said that different elements, different mass, size, and chemical properties. So now mass is not going to be different. For example, if we'll take, basically, let me take calcium. How many of you know calcium atom? What is the formula of calcium? Calcium is Ca. What is the calcium, mama? Ca. Okay. So calcium atomic number is 20. So if we'll take calcium 20 and mass number is 40. How much is the mass number? Atomic mass 40, all of you. So now if I take calcium atom, according to Dalton, every calcium atom having the same mass. Yes or no? Yes or no? All of you. And if I take another element, argon, let me take argon. Argon is Ar. All of you remember. So now, if I take the argon and as well as if I take the calcium, having the same mass or different mass, anybody can tell? Basically, according to Dalton. According to Dalton.
Different mass, sir.
Different mass. But if we take here, its atomic number is 18, means number of protons here 20 and here 18, but here mass number is still 40 only. So you see here, even though atoms from different atoms, but their masses remains constant or not, Hari? Yes, everybody?
Yes, sir.
That is what. So here, number of neutrons are balancing. See that number of protons are not same. Here protons are 20, here protons are 18 only. So here number of protons plus neutrons are 20 plus 20. But here number of protons is 18, number of neutrons are 22. So that is why even though the atoms of different elements, their mass is same, means mass number is same. So these kind of things, before you check it, what is the definition I said here? Read it, everybody. Same atomic number, but what is different? different mass number is called as isotopes. Now, same mass number, not atomic number, guys, but different atomic number. Different atomic number. Can you understanding, everybody? Gokul, Akilan? Different atomic number is called as isobars. What is to call? Isobars. 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 Please remember, same mass number, different atomic number. So this is also become drawback of Dalton's theory, because by his time isobars are not identified or discovered. Is it okay, guys? Yes or no? All of you?
Yes, sir.
So these are the disadvantages of Mr. Or we can say drawbacks of Dalton's atomic theory. So whatever he has been said, it has been proved, like these three properties. So different atoms of same atoms of same element is always having same mass, he said, but the atoms of same element may have variable mass, or the atoms of different elements may have the same mass. So that is what isotopes and isobars. So that is what you have to remember. So these are the three disadvantages of or drawbacks of Dalton's theory. Anybody is having any doubt? Please kindly let me know. Are you all understand or not? Yes, Arini, Abhinami? Yes,
Yes, sir.
that is what everyone please remember. These are the disadvantages. Anyhow, chapter 4, we will study again what is isobars and as well as what is isotopes very clearly. Now, as it is the situation, so just I want to teach, so that I am teaching you this. Okay, so that is what it is. Anybody is having any doubt? Anyone can ask me. If no doubt, then right. Next concept which we are going to study is atom. Please, all of you keep reading atom. Atom. Any doubt, Mitakshri, Hari? All of you keep reading. What is an atom? What is an atom? That is what our heading now. We are going to study what is atom. What is an atom? What is an atom? Now, suppose you might be know the wall. How many of you have seen the wall? Harish, Gokul, Mitakshri. Do you all have seen the walls? Everybody? Wall is constructed with what, guys? Anyone?
Bricks.
Bricks. So now here, entire wall is called as matter, and every entire wall is made up of indivisible bricks. Bricks are joining together one after one. One brick, second brick, third brick, fourth one, fifth one, sixth one, seventh one, eighth one, ninth one, 10, 11, 12, like this. So many bricks kept together, that is only will form a wall. So you might be all notice that. So like how our house or wall is made up of thousands of bricks is kept or arranged. Same way in chemistry, a matter is also made up of every brick, like brick is considered as an atom. So every brick is considered as atom here. Same how we are constructing a big house with a joining of every individual brick one by one. Same way, every matter is made up of what, guys? By joining of so many smallest particles. What is that called as? Everybody? Yes, please. So many smallest particles. They are only called as what? What is it called as?
Atoms.
Called as atoms. So that is only called as atom. What is an atom means? Please write a definition. An atom is the smallest particle of an element An atom is the smallest particle of an element. Atom is the smallest particle of an element. Who is involving in chemical reaction? Everybody, anybody? Who is involving in chemical reaction? Who is involving in chemical reaction? Atoms. Please remember, an atom is the smallest particle of an element. An atom is the smallest particle of an element. An atom is the smallest particle of an element that can take part in a chemical reaction. Element that take part in a chemical reaction. Is it okay, guys? That is the definition of atom. Any doubt? Agilan? Johan? Okay. So remember, these atoms are, most of the elements are very, very reactive and they do not exist in the free state. So means single atom cannot be existed, most of the elements. So they are very, very reactive. So that is why single atom cannot be exist. Single atom cannot be exist. So that is why always they will be combined together. That is, they will exist in combination with the same other atoms of the same element. So there are so many kinds of atoms as are elements. So till today we are having 118 elements known to us. So means 118 different atoms known to us. So these atoms only, each atom, they cannot exist single. So that is why they will combine of the same element and they will be always together. Okay, everyone? Yes, please. Understand? Everyone? That is what you have to remember. Now, atoms are very small in size or bigger in size? Anybody? Abhirami? Atoms are very, very small in size. That is right. Atoms are very, very small in size. 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 So for example, sir, how much is small? You might be asking me. So if you'll consider basically, sir, how much bigger, how much small, if you'll ask. So if you'll take, for example, a small size of atoms can be had from the fact, like you can take, if you'll arrange, it's around like, you can say 35,000,000,000. How much we can get? 35,000,000,000. How much it is? Anybody can tell? I think 35 crore. Is it a sorry? How much it is? Value, read.
3 crores 50 lakhs.
Yeah. So 3 crore 50 lakhs copper atoms. So imagine 3 crore 50 lakh people is standing in a line. How many kilometers will come approximately? Your guess. I'm asking. 3 that is what? How many kilometers will come approximately? Your estimation. Yes, please. 3 crore 50 lakh persons is standing in a line. Approximately how many kilometers will come? Anybody can tell? At least minimum 5 kilometers will come. Is it necessary? If you stand very closely also. More than 5 kilometers. Example I am saying. Now, 3 crore 50 lakh atoms. If we'll arrange side by side, like this, imagine of copper atoms, you will get a distance of only how many centimeters? How many centimeters will come?
1 centimeter.
1 centimeter means, is it a small or big? Anyone?
Small.
Very, very small. That is why I am saying, and atoms are very, 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 very small in size. If you take example, 3 crore 50 lakh copper atoms arranged end to end in a line, they would cover a distance of how much, everybody? Exactly 1 centimeter. Okay, so that is why the size of the atoms are extremely small and they are spherical in size, spherical in shape. So that is why we'll measure. It is indicated by, size is indicated by radius, which we used to call as atomic radius, or we can say radius of atom. Is it okay, everyone? So size of the atom, how we can measure? Size of the atom is measured in atomic radius, or we can say radius of the atom. Please write. The size of an atom is indicated by the size of an atom. The size of an atom indicated by radius of atom, radius of atom, which is called, or which is known as, what is to call, guys? All of you, atomic radius. Atomic radius. Any doubt? Nobody? Atomic radius. Is it okay, everybody? Yes, and right next. Atomic radius is measured in, atomic radius is measured in, atomic radius is measured in, what is the units? Anybody can tell? You, by this time you might be know, some of you at least. What is the unit of atomic radius? Harish, Gokul, Akilan, Abhirami, anyone? Any Johan, they will never say. Yes, please. Hari?
Nanometers.
Very good. Nanometers. Measured in nanometer unit. And the symbol of nanometer is nm. nm indicating nanometer. So it is the extremely small unit of measurement. Okay, extremely smaller unit. Smaller unit in measurement. Okay, so how much means? Remember, if I'll take basically 1 nanometer is equals to 1 by 10 power 9 meter. 1 by 10 power 9 meter means in the sense of, it's like 1 billionth of a meter. 1 billionth of a meter. That is what you have to remember. So we can say basically, so 1 nanometer is equals to, all of you remember, is equals to 1 by 10 9 zeros. Three, 6, 7, 8, 9. That is what? 9 zeros meters. So now this 9 zeros means how I can write? 10 power 9. Can I write it or not? Mathematics. Yes or no? That is what. So from that, 1 nanometer is equals to 1 by 10 power 9 meters, or I can say 10 power minus 9 meters. So this is what the size of the atoms, measurement, nanometer. And you learn our knowledge, 1 meter is equals to 10 power 9 nanometers. Is it okay, Harish? Mitaksri? 1 meter is equals to 10 power 9 nanometers. From that, reverse if we'll do, 1 nanometer is equals to 10 power minus 9 meters. That is what you have to remember. Is it okay, everybody? Yes? So now, suppose example, hydrogen you will take. So if you take hydrogen atom, as we know, it is the smallest atom. Its atomic radius is, its size is 0.037. So what is the meaning of nanometers? Means how many meters? Anybody can tell? In the form of meters, how many meters? How many meters? Yes, please. How many meters? 0.037 into 10 power minus 9 meters. Means it will come like this. 0.00000000037 nanometers. Understand? Sorry, meters. So this much big will come. So that is why we are writing in the form of powers. Is it okay, everyone? Are you understand? Harish?
Yes, sir.
That is one. So hydrogen atom, if we take, what is the size of the hydrogen atom? 0.037 nanometers, or 0.037 into 10 power minus 9 meters. Okay. Now, if we take the most favorite thing of girls, gold. If we take gold, do you know that what is the size of the gold atom? The size of gold atom is 0.144 nanometers. Means how many meters? 0.144 into 10 power minus 9 nanometers. Are you clear, everybody?
Sir, meters, sir.
Yes, meters. 10 power minus 9 meters. So this is how we will measure. It's the smallest one. All of you should remember. It is the smallest one, which we used to call like atoms is extremely small in size. Always will measure in nanometers. So 1 nanometer is equals to how much, guys? What is 1 nanometer means? All of you.
10
Nanometer means 10 power minus 9 meters, or 1 by 10 power 9 meters. Everyone should learn this. So till here you learn. Then in the next class we will study what is how big these atoms are. That is what it is. Now if we take some real life animals and all, we'll see how much it is. Like they have given in our page number 33 some ant size, hydrogen size. Atom of hydrogen, basically we can consider like in meters. Approximately it is equals to 10 power 10 meters. Okay. Molecule of water and molecule of hemoglobin, grains of sand and apple, they have given the sizes there. So you can see that. So 1 nanometer is equals to 1 by 10 power 9 meters, means 10 power minus 9 meters. And 1 meter is equals to how many nanometers? 1 meter is equals to 10 power 9 meters. Okay, sorry, 10 power 9 nanometers is equals to 1 meter. So learn that too. Then we'll study in the next class. So what is the symbols of older, the historical symbols, and later the symbols, that is what proposed by John Dalton. Later different other modern day symbols, that is all we'll study in the next class. Okay, later we'll go with atomic mass and atomic number, and later we'll solve how do these atoms are existing, how we'll measure, that is all we'll study. Okay, so with this I will stop the today's class. From here we'll continue the tomorrow's class. Thank you, everybody. We'll meet tomorrow.